Hello, everybody, and welcome to the next OpenValue meetup. My name is Mauro Palsgraaf. I'm software engineer at OpenValue, and I will be the host of this evening. Due to the lockdown, we cannot record from the studio, but we try our best to make this meetup go as smooth as possible. We will start today with a presentation from Kevin, who's going to talk about visual recognition with machine learning. We will follow this up with a 15 minutes break to give everybody time to get a drink. And afterwards, we will go to Braam, software developer of JPoint and founder of OpenValue Amsterdam. He will present about end-to-end testing environments. Important, if you have any questions during the meetup, you can type them down in the chat so I can ask them afterwards to the presenter so that you will get your answers. Without further ado, let's give the stage to Kevin for the first talk.
Thank you, Maro. Hi, I'm Kevin Berendsen. I'm going to be doing my talk about GSR 381, visual recognition using machine learning. I'm also a software engineer at OpenValue, but also part of the expert group about this talk. So furthermore about machine learning. Machine learning is really recognizing patterns in data and making predictions against that data. So to give you an example, you can make a machine learning model that is able to recognize patterns in photos of cats or dogs, for example, and is able to make predictions based on new input data that you give it to. For businesses, for enterprises, it's slightly different or more or less the same. Basically, applied machine learning is in enterprises is to maximize ethical business benefit based on those predictions. So use those predictions to make business decisions really. So when you want to create a machine learning application, more or less, you can do that as long as you use Python, right? Python is a very popular language. Thinking about TensorFlow um, from Google, and but we are Java developers, right? So the majority of the viewers here as well are Java developers, and we're not alone. I mean, there are 12 million of us. So it's kind of weird that we don't use Java for machine learning applications, even when we want to. So already answering actually this question, why are we building GSR 381? First of all, we think that Java needs to be a first-class citizen for machine learning. So it needs to be equivalent or near as good as Python is. And the reason why is that we don't want JavaScript doomsday scenario happening again. Um, as well as everyone knows now is that JavaScript is really popular uh, for for web-based applications, and it's pretty much the only choice that you have to be doing that. And we don't want um, to allow Python to end up like that. So that machine learning can only be achieved via Python or another language called R. And I think that Python is a very good language. I've tried it myself. I've used it from time to time myself. But I think that, and my colleagues as well, think that machine learning should be widely available across other languages as well that you are very comfortable using. For me, that would be Java. And Java is a really great language. As a user ecosystems of 12 million developers, it also allows more machine learning applications to be built if you only know Java and when you don't know that much about machine learning. Same for me. So what's the GSR gonna offer? It's a standardized Java-friendly API for visual recognition. So we'll be focusing on visual recognition tasks specifically. It contains a generic machine learning API. However, we will definitely be focusing on the visual recognition part, but the generic part for machine learning is one of the things that we think that's also very necessary to embed within this API. And from the start, from the get-go, there are already multiple implementations available to choose from. You will be able to choose from the reference implementation, which is the default implementation that you can pick. It's pure Java, by the way. And then you can also choose another implementation that will allow you to use Apache MXNet or TensorFlow, for example. And we built this API on a high level abstraction. So you don't need to know a lot about machine learning. Actually, you need know a lot less about machine learning than you would think of using this API compared to other APIs. So we started while we started building the API, we also started talking to companies, to very large companies actually. And when we talked with them, we always asked them the questions, why not Java, right? Why don't you use Java for machine learning? And they always came with, well, the APIs are not really not that great. The features um, that are built in Python are much more widely available than on other languages. So we started just learning Python and started using technology written in Python to accomplish those, to build those machine learning applications. And they were all very interested in what we were doing, and some of them already collaborating with us to make this API better. To give you an example, AWS from Amazon Web Services, is already working with us on integrating with our API, at least with implementing our API using uh, their own libraries that they own, and that also allows other users from who are previously using TensorFlow also to be using those models in Java and using a very simple API. So we think that's really great. So the solution is really, we need to promote Java for ML, and we need to start somewhere, and that's why we also picked facial recognition, because it's um, very visualized. So it's not just numbers and other mathematics that's applied, and then eventually there's a number that as output. Now we pick something that you can actually see, and that's much more convenient when you start learning building machine learning applications. So our API goals and architecture, the design goals and principles that we have, we need to enable Java developers to use machine learning using the Java skills. I mean, we've been doing Java for so long, why not use it for machine learning, right? And also it should be able to be used by non-experts in machine learning. I'm not an expert in machine learning either. Um, but once I've joined this group, I've come across a lot of experts that taught me on how to do machine learning, right? And what's and how easy it is to understand with an easy API, and that's currently not really provided, especially not in Java. And actually, I had to learn Python for it. So, and it should also, the API should also be easy to implement by existing machine learning libraries. And that's also something already we have proven about by allowing Amazon to implement our API. So what can you do with it? There are two main tasks, but the second task is somewhat part of the uh, uh, third task. So first, we're gonna allow users to classify images and data objects. So that's pretty much a classification task. And that allows you to either say an input image, uh, in this case, it's a penguin, or it could be a rabbit, right? So you train that model to be able to classify the input, whether the input is a rabbit or a penguin. And the second task would be to estimate value, which is a regression task. So that's something that we won't, which is not necessarily linked to a facial recognition, but it's definitely a part of um, the third option, which is object detection. So that's a very popular one when you're thinking about facial recognition. Is what you would usually see when you would Google for facial recognition, for example, that it detects objects in a certain image or video stream. It's able to locate objects and then classify it. So it's using regression to calculate a potential position of an object, and then classification happens over that position, was also called a bounding box. And then if it returns a certain threshold, it will return um, whether it's classified or not. But we will primarily be focusing now, also in this talk, on classifications. So like I already mentioned, is that we got classifications here. We know as humans that um, this is a puppy on the right side and on the left side it's a kitten, right? But a computer doesn't know, and a computer only sees bytes. So we need to make the machine understand that on the left side is a kitten and on the right side a puppy. We also call this, because we're only talking about two classes, we're talking about binary classification. So there are only two classes. When we talk about one more, it's we talk about multi-class classification. And also the binaries, uh, the name itself already says that it's binary, just it's a 0 or a 1. So either one of the two. When we go a step further, we got the object detection, which, like I said, is able to detect the position of a possible object and is able to classify that position. We got two kittens here, a rubber duck, or I don't know whether they classify this as duck at the bottom, and a puppy again. And this is called, I've got an incorrect header here, but it's instance segmentation. So for the classes that, for the objects that are detected, we can also cut them out by using some sort of masks that are applied within instance segmentation. So you can really cut that out, cut the objects out, instead of just a bounding box. So when we talk about the architecture here, is that, like we said, we want this API to be very easy to be implemented. So the apps or the libraries that are going to be using our API are talking most likely via our public API. So the public API are a visual recognition task related. So they'll be using the visual recognition layer. And then that visual recognition layer, we got the generic machine learning layer, which already mentioned that that's just necessary to implement. That also allows machine learning engines to implement our APIs much better by using our interfaces or classes. And the way they're doing that is we got a service provider interface that has certain methods and that's able to provide a certain implementation. So when we ask for let's say an image classifier, for we want to do the image classification task, there could be multiple implementations within the machine learning engine, and they are based on input. They are able to provide an instance, a class instance of the necessary implementation. And fun fact is even that you can use multiple implementations at once. So already mentioned the reference implementation. So that's the default implementation, the basic implementation. We are using DeepNets. DeepNets is a DeepNets community edition to be exact. This is a Java-based deep learning library. Also, the owner of DeepNets is a part of the is one of the spec leads of this GSR. So we finally want to see some action, right? To get a better understanding why we are building this model, is we want to know the process of building a new model. So at first, which is not drawn in this this diagram, we first want to state and define the actual problem. Machine learning is really nice and great to be using. It's really fun building a machine learning model, but is it really useful? Could be there. 9 of the 10 cases, there are much more simplistic answers and solutions to be used than machine learning. Machine learning can be really, really tough at sometimes, especially when you have bad training data or no training data at all. Then building a model is not that really sufficient. But let's say that we do have a certain problem that can only be solved by machine learning up until now. So we continue by assembling the training data. So the training data is assembling the trainer data is really the hardest task that you must do, because when you put in garbage as training data, you get also garbage out. So the training data is should be really of high quality, and you should probably also have a massive amount of quantity to start creating a good model. For proof of concepts, you can use obviously fewer data than you would for a production machine learning model. But that's really that's always the hardest task to assemble that data. And for our demo, I've used 60 images of each classes. I've got two classes, which I will explain next. But I've got 60 images. They also they also have to be somewhat equivalent, and the backgrounds are also have also to be quite similar, which is also something important for machine learning models that aren't don't have that much of a training data set. So once you have assembled the training data for the first time, um, you're gonna create an algorithm. And for the GSR, we decided that neural networks are really common to use across many implemented machine learning engines. So if we wanted to cover most of the implementations, neural networks was pretty much the way to go. So we defined that already. And then you have to define the architecture of that neural network. But that's something that you don't have to be focusing 100% on. For especially for proof of concepts, you can just pick one with just a few layers, not 32, for example. It would take a very long time. So the more training data you have, and the bigger your architecture is of the neural network, the longer it's gonna take before it's gonna build the model. And um, yeah, so once we define that architecture, we're gonna build the model, and we're gonna wait. Sometimes models can take weeks, months, maybe, I don't know, depending on the hardware that you have, and the amount. Like I mentioned, the bigger the architecture and the more training data that you have. And then you're gonna perform some evaluations to see how it performs. And then the feedback, you're gonna add that. You're gonna make slight modifications to the algorithm, maybe. But obviously, you're gonna be making a lot of modifications to your training data. So for the demo, um, we're gonna create a binary class image classifier, and it's all publicly available on GitHub. So what we're gonna do is we're gonna classify the input either as a Millennium Falcon or TIE Fighter. So that's slightly different than cat or dog or any other example that there is for classification. Like I mentioned, I've got 60 images of both classes. Um, so yeah, it wasn't the images quality is not that great, but it's sufficient enough to able to classify the input properly. So when we're talking about code, this is pretty much it. This is all you have to do in terms of code in order to create your model. So we're gonna start creating, we're gonna use the neural net image classifier, which is an interface and has a builder. We're gonna instantiate a new builder for it, and gonna say input class buffered image. And for each implementation, the buffered image as input is mandatory. Certain implementation can support different types of input, but the ones that we definitely wanted to support for all implementation was the buffered image, which is also a part of Java, obviously. So the input that we always give to the image classifier is going to be a buffered image. So next will be image height and image width. This also is linked to the input. So Some implementations are able to normalize the input data, and by normalization I mean it could be grayscaling the image because it doesn't understand colors, for example, or it could be scaling to these dimensions. So, for example, if the input is 150 by 150 pixels, it's going to scale down to 50 pixels. So that's what it could do, or it could throw an exception if it doesn't do normalization and these properties are required. Next will be the labels file and the trainings file. So the labels file contains the different classes that you have and the names of them. And the training file is basically a mapping between the data that you have and the classes. So for example, image one belongs should be classified as a TIE fighter. And that would look like this. So on the left side, we've got the labels file. We got two labels, Millennium Falcon and the TIE Fighter. On the right side, we got the mapping between the image that we have. So we got 5 images here, as shown in the example. And 3 of them are classified as Millennium Falcon. The others are TIE Fighters. So that's used in the learning process of building the model. Next will be the architecture. So like we give that as well. From what I know is that the reference implementation requires an network architecture, and AWS Labs don't demand a network architecture. They do that for you. So they define one for you. But we're using DeepNets for this demo, so we're gonna be defining that as well. So on the right side, we got the architecture overall in visualized, and we don't have to care about whatever is in between. We now only have to look at the input layer and the output layer, which is also defined here in JSON. So this is the actual file, and it's going to start with the layers input and always ends with output. And for us, what is really important is that the width and the height is equivalent to the width and the height that we give it as parameters to the builder. And then the output is going to be the number of classes. So the width of the output layer is going to be, for us, it's just 2 because we got a TIE fighter and a Millennium Falcon. So if we got another aircraft or vehicle that we want to add, we're gonna increase that number to 3. So next would be exporting the model. So obviously you don't want to train the model over and over again if you want to use the model as classification task. Obviously you want to store that away. So that's what this parameter is all about. And then we come across the last 3. So these are pretty much the the training parameters. The top 2, max error, max epochs, define when we stop training the model. So if the error rate hits below 0.03, we're gonna stop training. The same goes for epochs. Epochs is pretty much equivalent to iterations. So once it passed 100 iterations, which in terms is normally very low, but for our use case is sufficient enough, we're gonna stop training that model. And also this value 0.03, I'm gonna show you in a bit an example. And then as last, we got the learning rate. So the learning rate is a defining factor on how fast you want to go with the training. So if you've got a low learning rate, it's gonna take much longer to train the model, but the accuracy could be much higher when you speed up the process. And all these variables are not really there are guidelines for it. Want to set, but it's just a matter of experimenting and playing around with it. So, and that's also the reason why I found these values uh, convenient at low training time, and the accuracy wasn't affected by the lower amount of training time. And that's basically what you aim for. And then we built the classifier. So this is for deep nets. The output could be similar to this. And what I wanted to point out was the epoch. So here we got the iterations. Um, yeah, I skipped a lot of iterations because yeah, I just have to show you an example. When we look at the bottom two, 30, 33 and 34, it stopped at 20, 24. I mean, 23 and 24. It stopped at 24. So afterwards it completed training, but that's not really the variable that did the trick. It was the training error. So we are talking about max error. Once if you look at the first two iterations, the value is much higher and it declines pretty steeply. When we look at the last two iterations, you can see the difference are very minimal, and they're gonna be slightly decreased by the more iterations that you have. And we set the variable to 0.03, and it obviously hit below that value, so it's gonna stop the training. And eventually, it took 51 seconds to actually train the model. But what's like to use the trained model? So once we've completed, and let's say we're gonna close the Java application, we're gonna create a new one that's gonna run on a Raspberry Pi or something. And what we want to do is we want to import the model and start classifying input. So the only main difference here is that we got an import model functionality that's able to import the model, and that's just it. And then you can use the classify method of the image classifier. And now I want to actually demo that. So I've got a trained model. You can also download it, and you can also train the same model. It's gonna give you the same output as gonna show you now. So what I'm gonna do is I'm gonna spin up a JavaFX application that is able to import a model. So here I have it. I have a small GUI. It's not really that lean, but it works. So what we're gonna do here is we're gonna open a model. Already trained the model. So if you haven't trained the model yourself yet, but still want to use the trained model, it's available within the root deepnet and then trained model dot dnet. Or if you once you've trained it, it will end up in the root of the project as towers.dnet. So I'm gonna open the model. It's gonna load for a bit. Now we know it's loaded, and now it's also available to open an image. So what we're gonna do here is we got test images. So these images should definitely not be included within your training data set. You usually got a test data set and a training data set, and they never should contain each one of another. So we're gonna start with let's go with the Millennium Falcon. So here we got an image. It's quite a light image, 21 kilobytes. Gonna open it up. It's gonna show up within the JavaFX program, and once we hit classify, it's gonna show us results. So here the classification model that we created is saying that the input image is 87%, and that's pretty high. I do know, for instance, that other images which are less of quality. So when we pick this one contains various other accessories on the image, which definitely should not be there, but it's still able to classify that image as a Millennium Falcon, which with not that high of accuracy, but it's still sufficient enough, especially for the demo, to be able to tell that it's a Millennium Falcon. Let's do that also for the TIE Fighter. And yeah, these images are pretty much from Google. So I picked them just from Google. So these are very much different from the data set I have. And I'm also going to show you the images that I have for the data set. And so this one is actually very low, but still sufficient enough. And also to give you, let's say, a 10 second demo, I'm going to show you the images that I have. So here we got an image. It's 21 kilobytes. Gonna open it up. It's gonna show us results. So here the classification model that we to let you know that this one is pretty dark compared to what we use for training. This one is much better and also gives a much higher accuracy. And also came across that the Millennium Falcon is much better classified. It's also probably due to the shape of the aircraft that we use for training. So now that we know that the model is um, sufficient enough, we can then start working on improving the data set. Unfortunately, for Star Wars aircrafts, it was pretty difficult. So once I started working on this model, I also came across when I started adding a third aircraft with also 60 images at the um, the machine learning model wouldn't just train properly anymore. The accuracy would be very bad, and so that's why also the reason when we need much more and much better images than we have now. So it's showing you from a Star Wars movie the aircrafts that are captured. So that's is for the demo. Yeah, thank you for uh, watching the presentation about GSR 381. If you got any feedback or you want to contribute, please do so. The group is down below. So thank you. Are there any questions, Mauro?
Yeah, thank you, Kevin, for this great presentation. Yeah, I got 3 questions actually. So the first one is, how will JSR be distributed? Will it ship as part of JDK, or do we need to download it somewhere?
No, so yeah, we got that question a lot. Um, no, it's not gonna be part of the GDK. We did talk about it, but we first gonna release stuff like you would have to download via dependencies, like Jakarta EE and Java EE, like you used to. So it's not gonna be part of the GDK. So even you can download the dependencies now. They are on Maven Central. So
Cool. Sounds nice. The second question is, how do you actually join a JSR like this? How did you get involved in this project?
yeah, I just started attending the meetings and then yeah, doing small tasks and then grew into it. So I've been doing it for years now.
Was it easy to contribute to it? Like,
Yeah, at first it was especially wasn't really my expertise. It was hard, but they helped me understand machine learning much better, and that allowed me to contribute also via code. So that's pretty cool. So you learn a lot, and you learn a lot of new people.
yeah, that sounds sweet. And the last question is, what are the next steps for JSR 381?
Um, so there are missing pieces that we still want to implement, and we still want to ship it with with this GSR, and otherwise we would have to create a new specification request. For example, we primarily focused on image classification, but still want to do the object detection as well. And also what we think is important that we start working on open standards. Um, for example, the models, so that the models that you would create with this engine can also be used, for example, by TensorFlow and Python. We're talking about the Onyx format,
Mhm.
um, stuff like that, video streaming, so that you can that would also be a next GSR to allow video streams to be part of as an input, and also use hardware acceleration. This is also not a part of this GSR, but that's definitely one of the most requested features that we got, is to also use hardware acceleration.
Sounds interesting.
Yep.
There are actually more questions coming up. So
Okay.
let me read it for you. One question from Roy Wasse. I think the co-sponsored this JSR partially. So he thinks that AWS co-sponsored it. Is that correct? And are they going to implement this? Do you know that?
Yeah, so AWS already has implemented it,
Mhm.
and they're also part of the expert group. So they also attend our meetings, and also they are even implementing their own sort of API, which allows which require native libraries, for example, TensorFlow and MXNet. That's what they are primarily focusing on, and because they are implementing also our API, that would also expose TensorFlow as one of the implementations to us. So that's one of the greatest contributions that they did for us.
Cool.
And I also got a really cool example, which which is able to classify um, certain certain images whether of lungs, whether you have corona or not. So they have some sort of corona classification
Wow.
examples. That's also nice to look at.
The next question is from Wouter Oet. What do you like most about this JSR?
It's really just that simple to use. When I started learning machine learning in Python, I had no idea what I was doing, and the results were just like from the tutorial. I couldn't create my own results. I wasn't at first, and that's what I like about this is just really plain. We've got a very simplistic API. We don't allow that many parameters for customization, and yeah, it's just you create just one object and you can start classifying new input. I think that's one of the one of the things that I like the most.
Sweet. That's it. Besides from a couple of thank yous, and Frank
Thank you.
Greco says excellent presentation. So thanks for the presentation, Kevin.
Thank you.
For now, we're gonna have a small break. Let's do till 5 before 8, or yeah, let's do 5 before 8. Then we get back. So we got 18 minutes break, so you can get like a new drink, or and then we can get back to the second presentation from Roy Braam. Thank you. Welcome back, everybody. We will continue the meetup with our second speaker, Roy Braam. He's a software developer at JPoint and the founder of OpenValue Amsterdam. And he will present us all about end-to-end testing test environment. Roy, please take it away.
Thanks, Maro. Okay, so let me introduce to you the Duke of False Positives, the Prince of Time Consumption, the False King of the North, the feared opponent of CI/CD, the gold digger of IT, the struggle of DevOps teams, the challenger of patience, the master of frustration, the end-to-end test environment. The place nobody wants to be. The spaghetti that nobody can unravel. It currently looks like production, and then it isn't anymore. I'm Braam. Like Mauro said, I work for JPoint as a software developer, and I'm also a founder of OpenValue Amsterdam. You can find me at Twitter. My Twitter handle is there on screen. And I have a love-hate relationship with end-to-end test environments. Like over the years, at different customers, I struggled with these environments, and I got involved in a lot of discussions about them, and I just want to share some of them. So let's talk about architecture, because when we talk about architecture, we talk a lot about production architecture. It's one of the top topics on birthday parties, some birthday parties. And when we talk about architecture, we mostly talk about how we are deploying our stuff in production and how it looks like. And we start with a monolith server, of course, because that's where you should start. And where you start thinking about, okay, how can I make it bigger? I want more structure, more teams. I will make it modular. Still running on a single JVM, so you make it multiple modular monoliths on multiple JVM servers. And of course, at some point you'll start thinking about microservices, and that's the solution for everything, of course. So you start thinking about 12-factor applications, network I/O, resilience, separation of concerns, etc., etc. But still, these are on real iron. So you start making them virtualized in VMs with even smaller ones. And because, of course, you can make VMs quite easy, you start separating them more. And then, of course, you heard about Docker, so you start also doing Docker, because then you're not so tied anymore to the VM's internal OS. And if you get more and more of these nodes, you want some management stuff like Kubernetes, etc. You get controllers, managers, APIs. It's all about this kind of architecture. And you go, of course, to the public cloud, because that's what you want. You want to be fully virtual, everything. Instead of a data center, you want to have a credit card. And of course, when you want to have it secure, you'll just add blockchain. So before you know, you have something like this for hosting your blog website, right? And all these heavy loading of architecture, etc., for running this simple application takes you a lot of time to maintain it. And of course, then you go to serverless, and then all those maintenance is gone, because serverless is without service and network, etc. So you're done. But the point is that all these discussions about architecture are about production environments. So how are you going to put your architecture in production? And they are less about non-production environments. So how are you going to develop your software in the stages before production? Most of the times, the only requirement is it should be production-like. So in this talk, I want to get some agreement on what's the definition of end-to-end test environment. So we both understand the same things about these environments. I want to share the problems the way I see it. I want to share some experience. I also want to share the reasons why people are using it. Some of the alternatives, I think, can help you without having these kind of environments, and hopefully some questions. Let's start with the definition. So what is an end-to-end test environment? So how I look at it is it's a complete integrated environment with production-like systems with a single purpose of testing. The last part of the sentence is important. So it's there's an environment, you don't use it for customers, etc., but you only use it for testing. So there are a lot of aliases, and I probably missed some. If you have more aliases that I missed, please send me a Twitter message, because I will add them to the presentation. I really love aliases of end-to-end test environments, because you will hear the weirdest names like chain environment, or a user acceptance environment, a production acceptance environment, a broad stack environment. And that's actually how I think Martin Fowler started mentioning these kind of environments years ago. Retailer test environment, theory, and I like that one the most, because in theory it works, but in production it doesn't. Acceptance environments, pre-production environments, enterprise-wide integration test environments, full stack environments, production-like environments, fake news environments, probably that has something to do with President of the United States, and staging. So probably you recognize some of them, maybe not, but all these names are naming the same thing. Like I said before, a broad stack or a test environment that has the only purpose of testing. So what's the problem of these end-to-end test environments? So in IT, we moved on. So I think for, let's say, 10 years ago, these environments were pretty stable. People start using them. But we still use these kind of tapes to make backups, right? So back in those days, we were deploying software once a year or once a half a year, etc. And we worked in big teams that all knew what was happening. And there was never a problem actually with these kind of environments. But things moved, and we now have multiple DevOps teams that have their own responsibility and their own independence of deploying software. And now these kind of environments become a problem, because it's impossible to deploy independently software. So one of these problems is a test data hell. So if you look at the test data, and let's say I'm responsible with my team for the shopping cart, I also have a catalog service where I get all the product information, and I have a stock service where I fetch all the information about how many items are there still in stock and if I can deliver them, and I show all these things in my shopping cart page. So let's say I always have to arrange test data, because if I want to have something in my shopping cart, I want those items in a catalog service, and I also want them in a stock service. So if I want to test this in an end-to-end test environment, I need to arrange this test data with the other teams. If you consume items, let's say you hit the checkout button on the shopping cart, you will actually consume data in the stock service, because the stock will go down, hopefully, if your test is succeeded. So consuming this environment, consuming this data means that you have to rearrange it. It's also not your test data. Probably there are multiple teams running on it, and maybe others are also adding or removing stock, or adding catalog, or adding things to the catalog, or removing things from the catalog. And also this test data needs to be correlated. So if you have things in a catalog service, you also want to be sure that it's in the stock service. It needs to correlate. If it doesn't correlate, it doesn't make any sense to test it. So bye-bye independent DevOps, because this means you cannot test it anymore on your own in end-to-end test environment. You need multiple other teams to arrange and put these things in this environment for you also. And I hear many times people saying that it's production-like, but I doubt actually about that, because if you look at a normal environment with, let's say, 4 teams, they have multiple microservices deployed, or let's call it services. Doesn't matter if it's microservices or monoliths, but they're all deployed in a end-to-end test environment, and they all deploy their stuff. Normally, it would go like this. Of course, people will first put their new version into this production-like environment, in this end-to-end test environment. And when they're done with testing, they will move it to production, which means production is the same again as the end-to-end test environment. But what happens if teams are simultaneously testing it? So Team A and Team B are both deploying their stuff into production. Then for both teams, the environment is not so production-like anymore. Or some teams do multiple updates because their tests will fail, so they have to do a bug fix, they will deploy it again, and again, and again, and again. And these versions also become less production-like. Or that team that never deploys to end-to-end test environment because it doesn't work anyway, so they just keep on deploying it to production right away. So as you can see, everybody is doing his utterly best to make this production-like environment as non-production-like as possible. Also, let's have a look a bit about the test scope, because if we look at this shopping cart example again, there are some more services behind it, because the stock service has a messaging service that sends a text message to an operator to know if the stock drops below a certain level. The operator will get a notification, you need to order these items, etc., etc. So what do we want to test actually? So if we do this end-to-end test thingy, do we want to make sure that when we check out the items, do we also want to be sure that when a stock drops, that the operator gets an SMS or text message? Or do we actually want to test there? We want to be sure that whatever goes to the catalog service is correct, and whatever goes to the stock service is correct. So think about your test scope, because what parts of the environment are you actually testing, and what parts of the environment are you responsible for? So many heard other problems, and you will probably recognize them. The tests are always unstable because the initial state of a test is never the same. You have very slow feedback time because you need to deploy them in this end-to-end test environment before you actually can test them. It really will increase your time to market. This helps when you are talking with the product manager. And it's quite costly because these things run on real machines, real iron. Those also need to be paid. I'm not even thinking about the license cost of all these things. So these environments cost a really, really big money. So about my experience at a big Dutch bank. So to get the scale a bit right, this big Dutch bank has around 300 DevOps teams, and they have a lot of things that they will share their customers, like payment accounts, saving accounts, credit cards, insurances, mortgages, investments, consumer and large, for both consumer and large organizations. So they're really doing a lot of things. So they're not like say, a Spotify that just sells one product, right? They do a lot of things. So they really have a lot of different DevOps teams they build services that connect to each other, talk to each other, etc., etc. So it's a big environment. So they are really in love with a end-to-end test environment, because that way they all deploy their stuff in these environments, and they can test everything, and they know when they go to production that everything is correct. So they have it for more than 10 years. And one small point on this plate is that if you look at that orange box, I was working at that team that maintained that orange box, and within that orange box, 120 teams are working. So this is a real big scale. So they really love it. It's always broken, but still they love it. They actually love it so much they don't have one, but they had actually 5 of them. So we managed to kill one of these environments, but in the displeasure of this setup, with only 4 of these environments, they started making smaller environments that connects to parts of these bigger environments. And what do you do when things got broken? Like the black boxes, you just connect to other environments. So all these environments had numbers, and when things broke in one of these environments, they just connected it to a other environment to make sure that still that test is passing. And that really makes me cry. We actually had people at our desks that connected all these things together, and they were like flabbergasted that their test data was not correlated anymore. So it really was a big mess. But of course, even at this big Dutch bank, there's light at the end of the tunnel, because not all teams are doing this. So more and more teams are not relying on these test environments anymore. The team I work for is now already, like, I think 6 years not working with these test environments anymore. But still, teams have to support them. But more and more people are moving away from it. And actually, the nice thing, and I really like their statement there, is when they moved to the public cloud, they said, we're not going to do this anymore. We're not going to provide anybody with a end-to-end test environment. Get your stuff together, test your software, whatever you like, but we're not going to set up a end-to-end test environment anymore. So it was a real big statement, and I really liked it. So now we had all these worst things about these environments, but why are teams still working with these kind of things? So there are a couple of reasons I heard. I think most of them can be grouped by four of the items: test data, trust, immaturity, and compensation. So let's go by them. Test data. So test with semantic correct data can only be run in the end-to-end test environment. That's one of the statements I heard quite often. And if we look at semantic correct test data, which means, for example, if you have a customer endpoint, you do a request with an ID, a name, a surname, and a type. The type is quite important, and the type can be a string. That's within the contract here. But what can be in there, actually, the type? Can it be a wholesale, a retail, a private, a boring, a bad, or a greedy? So when you want to know what's in that kind of data, you need to connect to a production-like environment to see what they put in the data. Because if you can, of course, stub it, but then still you're stubbing a couple of strings, but you still don't know what the production-like environment has in mind about these types. So that's why they say this statement, a semantic correct test data can only be tested against a end-to-end test environment. But actually, that's quite wrong, because what you actually should do is make clearer specifications. So this types of strings can also be in the specification. It can be like XB 1, 2, 3, 4, 5, 6, and that's it. And if it's be a different one, then make the contract stricter. And if it's a test data that you're really relying on, move the test data out of the end-to-end test environment and make stubs out of it. And also, if your software is depending on these values, and your business logic is changing the behavior of your application, then move this test data to a lower part of the pyramid, because probably you can also test these kind of things in a unit test. And also build for failure. So if there's a type that you don't know, don't make your service end up with a 500 returning to the customer, but make it unknown where you handle it correctly and show the customer a nice message. One of the other things is trust. What I often hear is, I want to see it working before I go to production. So I first want to see it working in an end-to-end test environment before I go to production. Or actually, what I hear is, I don't trust the automated test we implemented. Or even worse, we don't have automated integration tests. We like the testing manual labor, because doing the manual testing labor is only possible in an end-to-end test environment. And that's kind of dangerous, because what happens if you don't talk the talk, click the click? What if you don't? What if this guy that normally does this testing by manual clicking, what if he forgets a certain scenario? If you run your automated test, you will never forget one of these scenarios, but it might happen that you miss one. And what if it fails? So if you use manual testing, the quality is not guaranteed anymore, because you can forget one. So start gaining trust with this, doing it without these kind of tests. So automate your stuff. Automate every test you can do. Most of the tests are able to automate. If you can't do all, do at least as much as possible. really invest in it, because in the long term, it will really help you. And if you have a bug, create a failing test case before you go fixing the bug. This way, you actually are proving yourself that you don't need this end-to-end test environment anymore, because that bug that you just introduced can be fixed with a failing automated test case in a lower part of the pyramid. And also invest in testing to gain trust. So I'm not saying it's easy, but the more you invest in these tests, the more you will be trusted that the software you develop and you put in production is bug-free. And whenever you can test a certain thingy in another lower level of the pyramid, do it. So if you can move it to the unit tests, that's awesome. One of the other things I hear quite often is System X had a new release that broke a system, even though the contract is the same. So actually, one of the other teams is deploying their stuff. The contract is still the same, but still it broke my system. So look at communication. I know it's hard at Corona time, but also when there's no Corona, when you look at some developer companies, you see a lot of people with their headphones on and not communicating to each other. And the team that broke their system is right next to them. So start communicating with each other. Try to see if you could solve these kind of things at a different way than the end-to-end test environment. Maybe you can talk to each other or something like that, right? And if it still breaks, make the contracts more stricter and clearer, because if they broke your system and they didn't broke any contract, then probably the contract is not clear enough. And if you can even go a bit further, start implementing consumer-driven contract testing. I will talk about that a bit later, but this way you can actually test the expectations from each other. And if it fails, then build for failure, because there are probably a lot of things you can do actually before you're actually failing to your customer. So if there is a problem with a certain service, you can probably do other things. I really like the Netflix example. For example, they show you recommendations, and when this recommendation service is broken, they just show you a different random recommendations that they don't care about, and the customer never will notice, but the thing was broken, but it's still okay. And if you're really depending on each other, so you're really tightly connected to each other, and the service is not between within one team, but between more teams, then start automate stuff on a one-on-one integration system. So don't tear up a whole end-to-end test environment, but start making a small scenario where you actually test against production-like environments from each other, instead of setting up a whole end-to-end test environment. One of the other ones, and that's I think the most complicated, is composition. So when they release a new version, we first want to test our system, because they often break things. So actually, here it is that teams are actually testing others' software, because they often they don't reach the quality you expect. So you are testing their software with the end-to-end test integration. So also look at improving by putting the responsibility where it belongs. Because if you are starting to test these end-to-end or doing these tests in the end-to-end test environment and test their software, they don't have to do anything anymore, because you will guarantee quality for them. So stop doing that, and actually talk with your PO, talk with the architects, etc., and start putting the responsibility where it belongs. So if it fails because of their problem, it's their problem, not yours. And this is a really difficult one, because it's, of course, it can have a big impact on your service. But also, again, become resilient. So if it fails, handle it correctly and try to make the user as happy as possible, even with a failure. And if you're really depending on the system and they break quite often, just run expectations against their environment. So, for example, nightly, run a set of tests against their environment to check their expectations you have from their system and their responses, and make sure that these expectations are every night met. So you're not tightly connected to an end-to-end test environment, but you keep those tests of the expectations separately. So what are alternatives and ways to minimize the usage of these end-to-end test environments? So like I said, as a improvement, a bit before in the presentation, you can start about thinking about customer-driven, consumer-driven contract testing. And I know that it's worth a separate talk, but let's try to do it within this talk, like a brief summary. So what's a C2C test? So consumer-driven contract test is a testing pattern. So you're actually, the consumer is providing a test, consumer-driven, and it tests the contract of a producer. It's about a test agreement between a consumer and a producer. And it's also about isolation, because this way you isolate actually the tests between these producer and consumer, and you're not trying to put up a whole end-to-end test environment. And what's nice about this is that the consumer always offers the expectations, and the producer tests with these expectations. So, for example, what can happen is you have a lot of different frameworks that can help you with that. But what you can do is a consumer, for example, offers a certain test as a pull request, and that pull request will be run every build from the producer team. So if you look at one of the frameworks, Pact.io, I can't say it any better, but this is on their website. Contract testing is a technique for testing an integration point by checking each application in isolation to ensure the message is sent or received conforms to a shared understanding. And this is documented in a contract. So this way, you can isolatedly test on any environment a certain test, a certain expectation, and you don't need a bigger environment with multiple services there. If you look at some examples, for example, you can send some expectations. So when I search for customers ID unknown, I will have a 404 back. And if I do customer / without anything, 400 will be returned. Or customers without a / a 200 will return. These are all expectations that you have when you are from a client call a producing endpoint. And you can make these kind of tests, and you can offer these tests to the producing endpoint to be sure that whenever you call these kind of things, you will get a proper answer. And of course, in these cases, the body can also be validated. So if we look at some characteristics of testing, you have isolation. More isolation is always better. Complexity, of course, lesser complexity is always better. Test data setup. Test data semantics, testing data semantics, feedback time, stability, reveal unused interfaces, well-fittedness, and cost and maintenance effort. So these are all characteristics of tests. Of course, they need to be as stable as possible. The lower the cost, the better. The less maintenance efforts, the better. And if you look at the different tests, for example, end-to-end tests, mock tests, and C2C tests, all tests that you can do some integration testing with, if you look at the end-to-end test environments, they're not scoring very well. Like I said, there's a reason for using these end-to-end test environments, because you can test data semantics with them, but they're not really isolated. They're always complex. The test data setup is a hell. The feedback time is slow. They're not stable because they are persistent. They reveal unused. They don't reveal unused interfaces. I will come back to that later. They don't show the well-fittedness of your application or your endpoints. They are really costly, and the maintenance effort is a hell. If you look at mock tests, they're always isolated. They're not so complex because you can follow them easily. The test data setup is easy because they're always the same. The feedback time is really quick, or should be really quick. They're stable. They are low on cost, and the maintenance effort is also slow. They don't show the review unused interfaces and the well-fittedness, but I will come back to that later with the CDC test. So if we look at the CDC test, they're scoring quite well. And with review unused interfaces is, for example, if nobody offers a test for a certain endpoint, it can reveal you that nobody's using that endpoint anymore. So, for example, you could say in your organization, like, hey, if nobody's offering me a CDC test for this endpoint or for these certain requests, I can just remove my endpoint because nobody's using it. And the same is with well-fittedness. You could also turn it around a bit and say, like, okay, I have a consumer and a producer. Why not start with what the consumer wants? So why is the consumer not first offering all kinds of tests, like how they expect the endpoint to behave, and then as a producing part, they start implementing them, because then you actually are quite well on your fitness of your tests. So this is all very nice, of course, but you will still fail. You will put things in production, and whenever you do end-to-end test environment or not doing it anymore, it will fail in production. So start minimizing the risks. So decouple deployment from release. So when you deploy your new piece of code into production with a nice new feature, make a feature toggle, for example, and make sure that the new functionality is not yet visible to customers. But first deploy your new software, and when time's ready, when everything's running fine, enable that new feature that you just implemented. This way you decouple deployment from releases. Start thinking about beta test groups. It's not always possible, but maybe you can have some, like for example, all employees that's using this product, and make them as a test group. And first let them test it before you release it to all customers. And one thing to actually know what's happening, of course, is monitor and threshold your alerts. So monitor your system, what's happening, know what's happening, and make threshold alerts. So if a failure is happening, make sure that you'll get a chat notification or an email, for example. And I know everybody's saying always, I always want to roll forward, but sometimes it will actually be much easier to roll back. So if it's possible, think about rolling back, and also think about how you can automate it. Think about canary releasing, for example, and I think I have time, still a bit time to come back to that later. Blue-green deployments, we'll also come back to that later. So for example, canary releasing, if you have a certain request coming in and you have a version and you're deploying a newer version, you can actually say, okay, 1% of my requests for a certain group of customers, for example, will end up to this new version. I will first see how it behaves, and before I actually send all the requests to the newer version. What you also should do is blue-green deployments, where you have a blue app, like your old app, you have a new app, green app, which you have a different route for. You actually first come to test it, just do a smoke test, is everything okay? If everything is okay, you also put that original or this URL on it, where also customers will end up in. You will monitor it and everything is fine. You will send all the requests to the green app and remove the blue app. And the green becomes your new blue. So to wrap it up, I really not say that you shouldn't do integration tests. I really like integration tests, keep on doing them. And I'm also not saying that it's easy to move away from end-to-end test environments. But what I'm saying is that a full-blown end-to-end test environment is not the correct answers to your problems. I know it's easy when you have one and you could use it, but most of the times the problems that you have can be solved by a different testing process. So please provide me any feedback, and are there any questions?
Thank you, Roy, for this presentation. There are 3 questions from the audience. There's one from Betjan coming, and it is, what's your experience with load testing? Do you still need end-to-end test environments for load tests, or do alternatives exist?
Yeah, that's actually a good question. I also, I think like also with load tests, it's quite important when we actually it's the same. So when you do end-to-end test environments and you do load tests on them, what happens if multiple teams do the load test at the same time, for example? So I don't think a end-to-end test environment is the correct answer of load tests. But what you should do is, for example, make your test your application actually how it behaves, and also mock all these other applications and try to think about, okay, what happens if that one is responding within 1 second instead of 100 milliseconds, and what happens if that service is not responding anymore? What happens when I put full load on my application? So I think also, especially for load testing, it's quite important that you also start isolating things and also start look at the boundaries. So if a application responds within 1 minute, then also see how your application is behaving, or how it behaves with 1 second. And you should mock these answers then also. And that's also not possible with an end-to-end test environment. So that's another point why you should move to a different kind of setup.
Thank you. I got another question from John. What do you think about spinning up testing environments on demand? Is that what do you think about spinning up test environments on demand? Is spinning up an entire test environment for a single test a good idea? What is your opinion here?
Yeah, as a consultant, I should say it depends, of course. But yeah, it really depends, because I think what's good about spinning up an whole environment is that you have initial state. So your test environments are much more stable than an end-to-end test environment that is persistent. So that's good. But of course, it depends like how much it will cost you to spin up these kind of environments. So I talk with people that say, like, for us, it's very easy because we'll do it in 15 minutes. We run our tests in 15 minutes, and we only do it when we are going to production. It covers a lot of quality for us. I think that's good. But like I said, at this big Dutch bank, that's not really possible, because then you have to spin up so many machines. That's just stupid. But yeah, it can solve your problem, and I won't say it's bad, because yeah, if it solves your problem, it's okay. But as soon as it becomes unstable again, etc., and multiple teams are using it, I think that's the wrong direction.
Good answer. I got a question from Roy Wasse. When would you consider manual user acceptance testing over automated testing? Maybe a legacy system? Question mark.
Yeah, I think that's always the thing, right? So, like I said, I'm not saying it's easy to move away from these systems, and most of the times, maybe a good choice is not to move away from it, because you have this legacy system. It will be gone soon, etc. You will just do a manual test because that's much cost efficient. But like the thing I didn't touched here, and I did it on purpose, is exploration testing, of course, because that's not really possible without a kind of production-like environment. So that's a whole different topic, I think. So I can imagine that you want to do an end-to-end test environment there, but yeah, still there are probably different solutions. So I would say never, but please always automate. But I think that's not the right answer when you're at the customer and they have a legacy system that needs to be tested.
Okay. If there's anybody, by the way, with more questions, fill them into the chat now so I can answer them afterwards. I got a last one, if there's nothing coming up anymore. In many organizations, you have monoliths talking to each other. These are not resilient, etc. End-to-end testing is then the only option to make sure upgrades don't cause unwanted behavior, many say. What do you think about that?
Yeah, I think that's correct, but still, you should, of course, there are lots of steps before that, because then we're talking again about the scope of your tests. So if you're responsible for the whole monolith, then it's probably nice to have these kind of environments, but that's not always the case. So probably you're only concerned about a certain part of that monolith, or let's say you are testing the whole monolith, then you can still mock and stop these kind of environments surrounding it, so the other mocks, etc. Because I can't imagine that you're responsible for all these monoliths, and if you're responsible for all these monoliths, then you might want to do some end-to-end testing. But most of the times, there are lots of steps before that. So you can easily test smaller functionalities in smaller cases, and you don't need to test them anymore in a end-to-end test environment.
Okay, and the last one that came in from Wouter Oet, how to deal with security testing. Security people prefer production-like environments.
Yeah, that's funny. I always have that question. Like when we stopped doing it, we had a lot of struggle with the security guys because they said like, yeah, but now we can't test it anymore. And we said actually, well, we can actually offer you all kind of responses for all the surrounding systems. Like we can provide all kind of SQL injections, all these kind of things. Just say where you want them. You don't even need to hack them anymore in there, like with some forms that is corrupted, but we can actually offer you all these kind of responses from these systems. So I think it's a different way of thinking. You should sec DevOps, of course, because the security guys should be involved much earlier in the stage, and they should also come with automated test cases for security testing and not do all these manual labor anymore on the final stage of your application. You should involve them much easier earlier, and then it should all be solved there.
Thank you. I think those were all the questions. If I look at the YouTube chat, if I missed any, let me know. Otherwise, I would like to thank you, Roy, for this great presentation about testing or end-to-end test environments.
Thank you, Maro.
So yeah, that's the end of the meetup. Thank you everybody for joining. If you don't want to miss any OpenValue meetups, please subscribe to the channel so you'll get a notification when we go live. I always wanted to say that once. This was the last OpenValue meetup of the year. So everybody from OpenValue wishes you happy holidays. Stay safe, take care of each other in these crazy times, and best wishes for 2021. Hopefully we can meet again in person soon. Thank you all and take care.
Bye.